So, the next is the Euler's theorem, which relates the normal curvature of a curve with the principal curvatures. So, the normal curvature k n in any direction, the normal curvature k n in any direction c, direction means a curve, along any curve, along any curve c at p, at a point p, is given by this k n is equal to k 1 into cos square alpha plus k 2 into sin square alpha, where k 1 k 2 are the principal curvatures, where k 1 k 2 are principal curvatures at p, of course, and alpha is the angle between c and the principal direction, the angle between c and the principal directions corresponding to k 1. So, the situation is this: on a surface we have some curve C, this is a curve C whose normal curvature is k n, and there pass two lines of curvature. Suppose this is one of the lines of curvature, let me call it C 1, and another line of curvature, call it C 2. So, their normal curvatures are k 1 and k 2. The normal curvature is maximum or minimum, whatever. So, k 1 and k 2 are the normal curvature of C 1 and C 2 respectively. So, since these two directions are principal directions, these normal curvature will be principal curvatures. So, the angle between C and C 1 is given to be alpha. So, if I draw a tangent to C and I draw a tangent to C 1, the angle between these two tangents is actually alpha, and we say it is an angle between C and C 1. All right. So, to prove this, our first assumption for calculation point of view is that we will assume C 1 C 2 to be parametric curves. Okay. We can always do this. So, assume C 1 C 2, I have not written, but I have mentioned over here that C 1 C 2 are the two lines of curvature. Assume C 1 C 2 the lines of curvature. As parametric curves. So, this normal curvature is the principal curvature k 1, and this normal curvature is k 2. So, the normal curvature k 1 here is, hence k 1 is k 1. If you remember the expression for k n, it is given by B I j dui duj upon gij dui duj. Now, since these curves C1 and C2 are parametric curves, so du1 is 0, so du2 is 0, so it will be just b11, when you will expand it, so du2 put 0, so only b11 will be left into du1 square upon g11 into du1 square, so it is simply this. So, k1 is this, and similarly k2 will be b22 upon g22 by the same formula and the assumption that they are parametric curves. All right. Let us assume that the arc length along C1 and C2 be ds1 and ds2. Let ds1 and ds2 be the arc length along C1 and C2 respectively. So, by first fundamental form, the first fundamental form is ds square equal to gij dui duj. For u1 curve du2 is 0, so ds1 square will be equal to g11 into du1. So, this is square, so this will become. Is it okay? Similarly, ds2 will be under root g22 into du2. So, these are the arc lengths along C1 and C2. Okay. Now, cos alpha, I have shown this angle, so you can see what will be the cos alpha. Cos alpha, I will say, is ds1 over ds. The length along C1 divided by the length along C. Okay. So, this is cos alpha, and this can be written as ds1 upon du1 into du1 over ds. ds1 upon du1 from this relation will be under root g11 into du1 over ds. This is cos alpha. Similarly, I can see the sin alpha also. Sin alpha, if you draw tangent here also, then this angle will be, since they are orthogonal, I can say it is pi by 2 minus alpha. So, cos pi by 2 minus alpha will be sin alpha. So, sin alpha also I can write down, this will be ds2 upon ds. Is it okay? And ds2 upon ds can be written as ds2 upon du2 into du2 over ds. ds2 upon du2 from the second relation here is under root g22 multiplied by du2 over ds. So, these are some relations that we have found. Okay. Now, Kn we have to see. Okay. I can rub off this part. Now, Kn will be equal to b11 into du1 square plus 2 times B12 into du1 du2, but B12 is 0 because the lines of curvature and parametric curves are same. From the last theorem B12 is 0. So, this is simply B22 into du2 square upon ds square I am right. Okay. So, this becomes B11 into du1 over ds whole square plus B22 into du2 over ds whole square. So, this becomes B11. I will divide from my side by G11 and multiplied also by G11. So, the first term can be rewritten in this manner. Similarly, the second term can also be written as B22 upon G22 into under root G22 du2 over ds whole square. So, look at what you have so many relations with you, number 1, number 2, number 3, number 4. So, you have pair of relation in all these 1, 2 and 3. Make use of them here. So, B11 upon G11 is K1. Under root G into du1 over ds from number 3 is cos alpha, and the square will give you cos square alpha. B22 upon G22 is K2, and this quantity by relation number 4 is sin square alpha. So, I am done. So, Kn comes out to be this. So, the normal curvature of any curve can be explicitly found related with the principal curvatures K1 and K2. It was in fact a natural question in our mind, what is the normal curve, how the normal curvature is related to the principal curvature. So, this is how these things are related among themselves. I stop at this point and we will continue in our next lecture some Roderick formula and other related things.